Good afternoon, everyone, and welcome back for our last lecture today on cybersecurity of operational technology. Thank you all for being here with us. Before we go on with the lecture, just again some brief details about the setup. So as you know, we soon have 50 minutes of lecture. And then 10 minutes are reserved for Q&A sessions. Whenever you have a question, please post them in the chat, not in the Q&A, because sometimes we have some technical issues and then some questions don't end up in the Q&A session. So therefore, please put all your questions that you have in the in the chat function, and I will, after the end of the lecture, read them out. Our lecturer today is Johan de Wit. Johan works for Siemens Smart Infrastructure as a technical officer and is involved in Siemens global portfolio development. He is a member of various expert communities and advisory boards, like the Dutch National Cybersecurity Center or the Information Security Forum. Without further ado, I hand over to you, Johan. The floor is yours.
Thank you. It's a pleasure to be here, and an honor as well to present to you about operational technology. And I'm not sure about the rest of the curriculum of this training, but at least I think that operational technology should be on the agenda, as it is a major topic. And I will explain during this lecture why I think that. Let me dive into the topic, and I'm not telling you all something new if I say we are in the age of digitalization. So we digitize, everything is digitized nowadays. And I looked for some definition, and it's kind of connecting everything with everything. That's kind of the shortcut to this definition. And this means that we're actually building cyber physical systems. So it's not only IT environments. No, we connect the all kinds of devices, appliances in our society, and by doing this, we make a so-called cyber physical systems, one or more cyber physical systems, and we connect them as well nowadays more and more to cloud. So we connect them to each other in different cloud-to-cloud connections as well. In a report by the Dutch. Made for the Dutch government a few years ago, it was noticed that this brings a lot of value, these cyber physical systems and digitalization in general for society, but it also brings some new threats as well. We connect all these systems together. And that leads to some issues, and I come to safety as well. It's not only the IT environment that might go down, but there might be some safety issues related to that as well, which we come back later on as well. And these, well, we live in a very dynamic geopolitical times, as we all know. There's a lot of tension around the globe, different areas. That also reflects into tensions in local societies too. And these all reflect or have effect on the cyber physical systems or the critical infrastructure. And the question actually is, it's no longer if it's going to be hit, but when it's going to be hit and what we're going to do about it. Now, these kind of questions are a few of the questions that I hope to answer in the upcoming 50 minutes. And that's something that this development is going pretty fast. I took this report of the Dutch National Cybersecurity Center of 2015, and it states that society comes to a standstill if systems go down and if there are no analog alternatives available. I had some doubts at this time already, but a few years later, this is a similar report of 2019. The Dutch National Cybersecurity Center acknowledges that there are no analog alternatives for the majority of our processes. So nowadays, our current society is completely depending on digital systems, both IT and OT. So, and if they go down, then we have serious issues in our society. So there seems to be a problem, and I hope to tell you a little bit about what we're going to do about that. But before we go into that, I was kindly introduced already, but a little bit more. So my name is Johan de Wit. I work for Siemens Smart Infrastructure for 26 years on these different topics that you see on the slide, looking at mega trends and have some forward-looking at developments both in technology and in society. Besides that, I got my PhD 2 years ago on the Delft University of Technology, where I studied security risk assessments by security professionals. And last but not least, I'm like mentioned as well, I'm a part of a lot of special interest groups, industry associations or expert communities, both in the cybersecurity world and in the physical security world. So I'm actually coming from the physical security background, so the guns, gates, and guards. But I came to learn that over the years, cybersecurity and physical security kind of intertwined or deeply connected to each other, and we have somewhat the same goals. I have some slides on that at the end of this lecture. As said, I work for Siemens. Well, Siemens is you might have heard of Siemens. It's a large global technology company consisting of several different units. So you see healthcare, where we do quite a bit. Siemens Energy for energy production sites, and the green ball, the Siemens Core. And the Siemens Core consists of three Siemens departments. Digital industries, so they are focused on automation systems. So everything that is that moves electrically with electric drives, it has some kind of automation in it. So it could be the elevator in your building, but it could also be a complete production line on in a factory, or maybe even in critical infrastructure, the control of a bridge or a tunnel system. So those are the digital industries. On the right side, you see the mobility. Siemens is also active in the mobility segment by delivering rolling stock like trains and trams, but also the infrastructure for that. So train systems, but also road systems. So like the entire tunnel systems is something that we do. And I'm part of the middle block, so smart infrastructure. And in smart infrastructure, we do everything around smart grids and smart buildings. Just to give you roughly an idea, I have about over 70,000 colleagues in this unit, and we do about 15 billion euros in turnover annually, somewhere around that. Within smart infrastructure, we have the so-called buildings department, and in the buildings department, we do building automation, fire safety systems, and security systems. And I'm part of the security group, so the physical security group. And like I said, that is kind of connected to cybersecurity as well, because as we stated, physical security is the first line of defense for cybersecurity. So it usually keeps out the bad people that you don't want on your side, or you don't want to give access to your networks or to your appliances. Obviously, nowadays you can access networks and appliances from the internet as well, usually, but the physical component is an important part as well, especially for OT systems. We come back to that in a second. So this introduction of myself and Siemens. Coming back to this question, we have a problem, and what are we going to do about it? I tend to look a bit at the European legislation that's coming up. Now you might say, well, I'm not living in Europe, so it's nothing to do with me. That's not entirely true. Europe has set up a cybersecurity or security strategy with a lot of components, and every organization that's doing business or has some kind of footprint in Europe needs to comply with it, but also the supply chains of these kind of organizations. which leads to the fact that although this is a European regulation and it's mainly applicable to organizations active in the European Union, these regulations are applicable to the supply chains as well. And a lot of the supply chains stretch out globally, and especially to the east as well. So although you might not be a part of the European Union, the organizations that you might work for need to comply to this security strategy as well. Now, this strategy led to a lot of regulations over the years. I'm not going to cover all of them, some of which you might have heard of. So the GDPR is definitely something that you might have heard of let me see here. Yeah, GDPR, so the General Data Protection Regulations, is something that is, like I said, European regulation, but every organization active in Europe needs to comply with that. So it actually, in fact, was kind of a global regulation as well. I will discuss today two of them. So one is the Cyber Resilience Act, but I would like to start with the NIS2 regulation. So, and that's a European directive, so the Network and Information Systems Directive. The first one, so the NIS, is introduced in 2016, and now we are at the second version of it, so NIS2. Now, a directive will mean that that's a mandatory regulation that is set by the European Union, but the countries in the European Union need to translate that into national legislation. So for the NIS, that already happened. For the NIS2, that was meant to happen in 2024, but a lot of countries postponed that a bit because we simply were not ready for that. Now, what does this regulation mean? It actually is expanding the responsibility of organizations not only to keep their own systems and their own IT and OT systems secure, but also make sure that the societal processes in society for this critical infrastructure stay secure as well. Just to give you an idea, having a system go down might not be very important for the organization itself. Of course, they would lose money. But if for instance, take a hospital, so a hospital administration system goes down for whatever reason, and the hospital needs to close, which costs money, but the societal impact of that could be really big because people cannot go to the hospital, cannot help, there cannot be any treatments done without this system up and running. And the NIS2 is set up by the European Union to have organizations focus not only on their own interest, so losing money, but also on the societal impact of their organization. And that's the main goal of the NIS and the NIS2. Now, what has changed over time? So we already had the NIS, and as you can see on this slide, on the NIS2 on the right side, the number of sectors that are considered critical, so critical infrastructure, expanded enormously. So on the left, you see the previous NIS from 2016, and on the right, you see the current NIS2. And you can see that a lot of domains, or a lot of different business domains are considered critical infrastructure and need to comply to the NIS2. So that extended quite a bit. There's some other things that expanded as well in the NIS2. So there's organizations need to do much more, and there's more coordination and more communication. But as you can see in the orange box, there are two things that I want to highlight. The first is that the NIS2 forces organizations to look at their supply chain and make the supply chain secure as well. So organizations are responsible for having secure suppliers in the supply chain. So although these suppliers might not be obliged to comply to the NIS2, their customers might force them to comply or to have cybersecurity in place. So by doing this, the European Union tries to get the entire supply chain, also the smaller ones, make them more cyber secure. So that's one major thing that changed in the NIS2. The second thing, also in the orange box, is that the management of organization, so the leadership of organization, is personally liable for cybersecurity. And this is done on purpose as well. So a lot of organizations, or the management of organizations, are reluctant to invest in cybersecurity. Obviously, it costs money and they might not see the benefit of it. Now, if something happens in an organization and the organization cannot or have not really documented that what they've done to make their systems and their processes cyber secure, cyber resilient, then it might be that the leadership of the organization can be held accountable for it. So they are personally accountable. And by having that in the new regulation, the idea is that a lot of organizations will have more appetite to invest in cybersecurity or security in general. NIS2 is requesting quite some actions now. This is not the first lecture that you have, so you see a lot of things that are pretty common in IT security. So I'm not going to go through all of them. So they probably look pretty familiar to what you should do when you do cybersecurity. So the regular stuff is written in this upcoming regulation. And for organizations, it's mandatory that they document what they exactly do with this, and that can be checked by the government as well. So the government agencies set up. That's why it's a little bit delayed in a lot of countries, because these agencies needed to be set up first, and they will monitor what organizations, if they do enough or not. So that's really a kind of structure behind that to make sure that organizations really comply to the NIS2. Now, before I go to the Cyber Resilience Act, I first dive a little bit into operational technology. You're all familiar with the information technologies, so IT. OT might be a little bit less familiar to you. So what exactly is it? And it's, like I said, it's the automation systems that were developed in the third industrial revolution. So maybe a short historical recap. So the first industrial revolution was steam powered. So when there were steam engines developed, we suddenly started to automate certain processes or power certain processes. The second industrial revolution was electrification. So instead of steam, we use electricity, which makes it more efficient and easier to handle. In the third industrial revolution, we automated systems. So we suddenly had these automation systems like PLCs triggering the electric drives. And in the fourth industrial revolution that we're currently in, we are connecting things. We're really digitizing that. And by doing that, we connect the automation systems, so the OT systems, operational technology, to the IT world. And in the third industrial revolution, so somewhere around the 60s and 70s, last century, when it's really started, those automation systems were separate systems. They were isolated and they worked. They had usually proprietary network connections, etc. So it was a kind of closed system, or air gapped, as we would call it now. With these, in the fourth industrial revolution, we started connecting things. We started using IP connections, IP networks. We extended networks outside sites and facilities. We make nationwide or even global networks where systems got connected. We had the Internet of Things coming up, or Industrial Internet of Things, so IIoT. So we connected devices and sensors directly to the internet, having cloud applications as well. So nowadays, IT and OT can hardly be separated. So OT systems use a lot of IT networks and hardware as well. Now, OT systems are known in a huge variety of names. So SCADA systems, PLC systems, industrial control systems, so ICS, or industrial automation and control systems, IACS, all kinds of naming. But in general, we use the term operational technology, OT, to encompass all of these kind of systems. And like I said, OT systems are actually all the systems that use some kind of electricity inside. So in my profession, so the building security systems like your access control or video surveillance systems, all these kind of systems are also OT systems. Like I said, we connected them. And something that is probably familiar, or should be familiar when you're doing something with cybersecurity or IT security, is the 3 elements of cybersecurity. So availability, integrity, and confidentiality. That's how we organize the cybersecurity for IT systems. Now, for OT systems, there's a 4th one that is really important, and that is, and you might have guessed it from one of the previous slides, that is safety. If an IT system is malfunctioning, that might be a big issue, but probably nobody gets hurt if the system is malfunctioning. With OT systems, which could be a bridge or a tunnel or a production process, if your emergency button, which you push if something goes wrong in your production line, if that doesn't work, then you might have a safety issue at hand, and people could get hurt. So that's a very important differentiator between IT and OT. That means that an IT system, usually IT systems, if they go down, let's say if the system goes down for 5 minutes, 10 minutes, half an hour, that's a nuisance. You cannot really work. And maybe production goes down at some parts. But other than that, nothing happens. If your your OT system goes down for 15 minutes, you're actually blind and you cannot see. You don't know if buttons are working, if your stop button or your emergency stop button is working, if you can open or even close the bridge again, if the barriers of the bridge before it opens or closes, if they would work. So actually, you have a kind of safety issue there at hand. That's a big difference between IT and OT. And in the end, we come to the kind of convergence of these 2 worlds. But a lot of cybersecurity is driven by IT technology or IT departments. They might not be aware of this difference with an OT environment. OT environments are usually done by operational teams, people that keep the factory running. That's a different kind of people than the IT people, and they might not understand each other. I come back to that. Now, there are more differences. If you have IT systems, and this is nothing new, we all have updates and patches and new hardware as well in your IT world. Every few years, you need a new software and or new hardware, a new laptop, etc. So we all know that's really short term. For OT systems, that's completely different. Imagine a train, which is an OT system with wheels. You wouldn't replace all your trains in 3 years' time. So they run 10, 20, 30, 40 years. They keep on running. So there's a lot of legacy in OT systems. You don't regularly replace OT systems. They stay, and they stay there for a long time. Also, update and patches. That's very common in the IT world. In the OT world, that's not as common as it is in the IT world, and there's a reason for that as well. Now, imagine that you have a train as an OT system on wheels. Suppose you do an upgrade of the software, some parts of the software of the train operating system. You must make sure that this update really works, and all the components and all the sensors and all the emergency sensors, that they really work after you did the update. Meaning that in a lot of cases in an OT world, if you did do an upgrade or a patch, you have to test the entire system, especially the security, safety and security features of such a system. You have to make sure that it really works. And that's a main difference with an IT system where everything gets updated and patched. And if it doesn't work, if something doesn't work, then you just roll back. In the OT world, if something doesn't work, it could mean that the train will not stop, for example. So you need extensive testing before you can make sure that an update and a patch is done. And of course, that will take a lot of time and a lot of money to do. So that's why updates and patches are less common in the OT world than they are in the IT world. Those are two major differences and you can read the rest for yourself. By the way, the slides will be shared anyway, so you if I go too fast, then you can read it. You can read them. Another difference between IT and OT is this timing. For an IT system, if it, like I said previously, if it goes down, that might not be an issue. An OT system should have real-time information. If I press a button to start something or to stop something, it immediately needed to react, and I cannot have some kind of latency that my emergency button just reacts after a few minutes. That's simply not possible. So we need these real-time systems, and that's why the availability in OT systems is one of the major factors. It's not so much about integrity or confidentiality, which is more in the IT world. In the OT world, we have the availability and the safety part. Having said that, this is a research in the meantime 10 years old, but it's still valid in a lot of cases. So IT and OT are managed by different units, and that's still the case. So different organizational units, different departments. So IT security is usually somewhere in the IT department. OT is managed by the operational staff, so by the business unit themselves. And these people, so the business unit, they do not really consider their system being vulnerable for IT IT threats, but they don't consider it IT as well. Although, like I explained, nowadays IT and OT are intertwined, so they use a lot of IT equipment to keep their OT systems running. They're simply not aware of that. So they see this train as a train and not necessarily as an IT OT combination system where they need to have a cybersecurity in place. So OT people, or ICS as they call it here, they lack security awareness. So they are really committed to keep the system running because that's their job usually, keep the process or the system up. But they don't have really a security background. On the other hand, IT people who understand security, and probably you are working or will be working in this domain, you understand that you need to keep your systems secure as well. But you might not be familiar with the differences between IT and OT that I just explained. So by having this lecture, I hope to give you some insights on that topic, so that you understand that there might be OT people in the organization that think differently and have a different goal set as well. Now, what can we do to secure OT systems? Some parts are similar to IT security. So we have the same kind of things like people, process, technology. We have these different layers, the defense in depth kind of principles, where you see site security, which actually that could be the physical security part, and then obviously network and system security. So you have different layers there. For OT systems, there's a different set of standards. And the major global standard is the IEC62443. And that's a standard specifically targeting OT systems. Now, it's a huge standard with a lot of different parts. So I'm not going to go too deep in this. I cannot manage that in 50 minutes. But if you end up in the OT world, please have a look at it. The different parts of the what is good about this standard is that it covers the entire supply chain. So it covers IT or OT security for suppliers, so producers of components of hardware. It has a set of requirements for the system integrator. So usually what happens, so imagine a new factory is built and a production process is set up. Then you have a system integrator building this production process, the production line, and implementing all different components from different vendors and make a solution out of that. So that's the second part of this standard that prescribes how the system integrator should build a secure solution. And the third part is actually for the people who are working with the system, so the operators. So how do the system can be delivered pretty secure with secure products, but if it's not used in a secure way by the customer, by the operators, then the security controls might not have effect. So this standard contains specific parts for these three suppliers, like these three components of the supply chain. So the product supplier, the system integrator building a system out of that, and the owner, and that's covered in this standard. Now, as you can imagine, there might be different security levels as well. Not all the OT systems are critical. You can imagine that the energy system of a hospital is a very critical part, but the air conditioning in an office building might not be a critical part. Although on your side of the globe, it might be more necessary than it is on our side. But well, the temperature in an office building is usually not a critical part to keep operating. In a hospital, that might be completely different. So you have certain ranges of temperature which you need for certain treatments. So then the same system can be not critical in an office building, but it can be critical in a hospital. So that's why you can have these different security levels for different systems in different contexts as well. The standard covers all these four security levels, and again over the supplier, system integrator, end user. So it's a very a kind of matrix-like standard, and it kind of prescribes what you need to do there. Small example for Siemens. Siemens is mainly an OT company, and we do two things. We are a product supplier, so we build products, we design and produce products which we set in the market, and we also have solutions and service departments. So we build solutions with it, and then we have the second part of the standard applicable to us as well. And there are two distinct processes, and the dotted lines, the dotted arrows, as I just explained, OT systems are up and running for 20, 30 years. So the dotted line actually extends far away to the right side of the screen. So that's the longest part, the life cycle of these kind of systems. And for all these elements, we applied the IEC 62443 for all the different elements. So for the design, so there must be a secure design of products. There must be secure testing, secure development. There must be security implemented in the engineering of when we build a solution, in the commissioning, in the service part. So all aspects of our organization are affected by this standard, and we have made we put all these requirements coming from the standard in the processes. Now, obviously, as we are a big organization, we have some governance around that as well. We have a lot of people implementing these processes and monitoring them as well. So all the people in the different departments are checked whether they do their work, when they comply to the regulations that we set up based on the standard. That's a little bit about OT and how we secure. Now, there's one regulation that's coming up. This is Cyber Resilience Act. Again, this is a European regulation, but again, this is also applicable to suppliers that are not located in the European Union. And this actually is dealing with the supplier side of things. As I explained, the NIS2 is applicable for the critical infrastructure, and they will demand secure products from their supply chain. The Cyber Resilience Act, the CRA, will come in a few years, will have effect in a few years. It's specifically focused on the supplier side of things, and it sets out also things that you can imagine probably. It will require the suppliers to have secure development of products, to have monitoring on vulnerabilities, to report vulnerabilities that they have. They needed to, well, instructions, they should be there anyway, but there also should be cybersecure instructions. There should be updates and patches available for products, and that should be available during the entire life cycle of it. Now, again, not all the products or not all the application of the different products is critical. So they set up this kind of metrics. There's a lot of products where there's kind of a self-assessment by the suppliers or the producers of products. They need to assess whether they comply to it or not. For the critical products, there are two critical class 1 and class 2. For the critical products, and they're usually the products that are used in the critical processes in the critical infrastructure, there are different assessments. So either you have a good assessment by yourself, or you have a kind of external assessor checking your the cybersecurity of your systems. And there are some examples for different products in this norm as well. Now, to sum up a little bit, and this is an overview from KPMG, which I like. It kind of sums up that there are you have the ISO 27000, which is more the IT norm, and we have the IEC62443, which I introduced to you today, which is focusing on OT. So it's different standards that are available. Obviously, a lot of the articles in the standards are kind of similar, so they kind of overlap, because a lot of things like identification and login procedures, etc., they might be pretty similar. And from a regulation perspective, European regulation perspective, you have the CRA, which is focusing on the supply side, and the NIS2 coming up for the demand side as well. So with these two standards and each two regulations, we kind of cover the entire chain of IT and OT security. I think time-wise, I'm pretty good. Last part. Let's talk a little bit about the convergence and so-called hybrid threats. And I already explained that I'm coming from the physical security side of things. I found this report of the ENISA, which is the European Organization for Cybersecurity, and they stated that a lot of cyber attacks or cyber threats have a physical component as well. And they call it the biggest backdoor of your system. And there's another report also from ENISA stating that in 2030, there will be an uptake on the physical and offline attacks, so joint attacks, so kind of hybrid attacks. So if we want to secure ourselves for these kind of hybrid attacks, we need to converge. And normally, if we talk about convergence, we talk about IT and OT convergence. Now, being a physical security guy, I would like to add physical security to that as well. Now, you might say physical security is a part of IT security, and you're right. Physical security is a part of the ISO 27000, but also of the IEC. But as it is a separate department, usually in organizations, I would like to stress that convergence is actually IT, OT, and physical together. A few words on convergence, and I've had some documents. This is from the Information Security Forum. The first step of convergence and the first goal of convergence is to get rid of the independent risk and threat analysis of the different silos in organizations, which could be IT and OT and physical, but also legal and business risks as well. And a lot of organizations nowadays have these kind of all these risks and threat analysis in a kind of joint platform, which is usually called enterprise risk management, ERM, where you combine all the risk and, more importantly, you balance all the risks. Now you might you currently this education is about IT security, so you might end up in an IT security department thinking that IT security is the most important thing in the world. Well, that might not be the case. And if you do an enterprise risk assessment and you compare IT security risk to OT security risk to financial risk to compliance risk to geopolitical risk, it might not be the biggest one. So the biggest advantage of doing enterprise risk management is that you compare the different risks from the different disciplines, and it's really interesting. I've been in quite a few workshops, in the enterprise risk workshops, where you have all the different departments talking about risk and try to find some common ground there. So one of the things about convergence is that you have this one holistic view on risks and threats instead of having all these different silos talking about their individual risks. In another report of the Security Industry Association, they have much more, and this goes too deep to discuss this entire matrix of components of convergence, but I kind of summarized it, took the highlights of it. We already discussed having this joint risk approach, so having both the risk side of things, so the IT, OT, physical, business continuity risks, but also combine that with business risks like your legal and financial risk or commercial risks, have this holistic view. Those are the first two. On the technology side, I have a next slide, and this next slide shows you what you would call in cyber kind of the kill chain. So this is the simple example of the kill chain. This is actually a slide from the physical security side of things, and you see kind of similar. It looks similar to a cybersecurity kill chain, and it actually, if you look at the examples below there, you even see that the naming is the same. So in IT security, you have intrusion systems. In physical security, we have intrusion systems, and we have perimeter detection, and we have security operating centers, etc. So the terminology is the same. The goals of all these systems are similar as well. One is more on the cyberological systems, and the other is on the physical side of things. But they are more or less aligned already by, I would say, almost by nature. In convergence, we also have these different standards, and we have covered quite a few standards already. But just to make sure, a lot of these standards, and also the NIST2 is talking about an all hazards approach, and it's not only talking about having this cybersecurity in place, but also think about the physical environment where your cyber systems are, or your IT and OT systems are placed. So you have to secure the physical environment of them as well. And there you see the compliance of these, the convergence of these worlds. Finally, convergence means also working together in organizations. And I took one slide from the CISA in the US, and it's a lot about cooperation in the different departments. So it's about communication, coordination, etc. So really working together, and they give some examples how you can work together. Now this seems very obvious, but in real life, and I talk to a lot of customers, Siemens customers, and I see that IT, OT, and physical security are not really combined in the majority of the organizations, and they don't even speak to each other in a lot of cases. And we see a tendency of change, so especially driven by the need to comply to regulations like the NIS, for example, where they need to work together and to have a kind of holistic approach to security. But in a lot of organizations, this will not be the case. So if you ever end up working in whatever domain, but probably IT security domain, please reach out to your OT security colleagues and your physical security colleagues as well. And convergence, in my opinion, is not only about security issues. It could be extended for more cooperation on the field of sustainability or resilience of the organization as well. So the different other topics that need a kind of a convergence of the different departments too.
Yeah. Oh, sorry, just 5 minutes. You have 5 minutes left.
I have my last slide to go, so I'm on time. Good, thank you. To summarize, I run you to security, mainly focused on OT systems, so operational technology. We looked at different regulations that are coming up, so bringing compliance, making security or IT and OT security more a compliance issue. But on the other hand, I also brought to your table the convergence topic, where we need to cooperate between the different, more between the different departments in organizations. This is kind of the summary, and this was my last slide. So I would like to thank you, at least for now, for your attention, and back to you for maybe questions. I don't know. Let's see.
Yes, thank you so much, Johan, for your presentation. I have to say I really enjoyed it, and it was very insightful, also for me, actually. Let me briefly have a look at the questions. So yeah, whoever has a question can definitely post that in the chat function. In the meanwhile, I actually have a question that just came up for me. I think you talked briefly about the NIS, I don't know, NIS2. And I was wondering, since this is like an EU-wide regulation, is it really applied in all member states, like sufficiently, so that OT systems are sufficiently protected, or is that also like an issue that not all agencies or states are aware enough of the risks of not doing so?
Good question. The NIS2 is not specifically focusing on OT systems, so it's about cybersecurity. So what we've done as an OT company, we raised attention for don't forget OT. That's kind of the thing. So and that's kind of the issue with governmental agencies as well. A lot of them are OT focused, IT focused as well, like IT security departments in organizations. So it's a matter of not forgetting OT. That's why I'm happy that I'm able to share this in this community, at least to bring this to the table, that please don't forget OT in complying to these regulations. Does that answer your question?
Yes, thank you. No, definitely. And like one question was like, even though of course like OT and IT, like as I understand it, are like two separate fields, is there still like, something in the field of AI or machine learning that can be used to sort of improve the security of OT systems, or is like, are the two domains too far apart for that?
Oh, definitely, and that's something that's done as well. So, like you said, there are two different domains, but AI is definitely used in OT systems as well, enhancing the efficiency and productivity. You can imagine if you take just an electric drive, so an electric motor, has about 2,000 data points giving information about the status of a motor. It's not simply running and how fast it's running. It's about energy consumption, it's about temperature, it's about noise, it's about vibrations, etc. All those things are measured, and so a simple electric motor in a production process generates a huge amount of data. And well, when there's a huge amount of data, then you can do a lot with AI as well, checking for deviations in, for instance, if AI would know the pattern of the vibrations of a certain production line. If that starts to change some way or the other, or at some points in time, then that could be an indication that something's wrong or something is going wrong. So it can be preventive. So it's definitely used. One of the downsides of a lot of OT systems is that organizations are reluctant to connect them to cloud applications or to get that data outside the factory because of the risk of having being depending on connectivity or cloud availability. As I said, OT systems, for OT systems, availability is the key element next to safety. So it should be running. So you cannot depend on a cloud or cloud connectivity for your system to run. So it could make sense to have AI on the back end, but not for your primary process.
Okay, thank you for that. One of our students is asking, or actually has like a couple of questions. The one relating mainly to training in OT system security, and he has pointed out that Siemens apparently provides training on OT security, and as I understand it, whether there's like a way to access this training and how this is done. So are there like any lectures, as I understand it, or courses that you can access as a user to get more knowledge on how that works, if I'm correct? So basically,
definitely, yeah.
Okay.
Now, obviously, that I can speak for Siemens, and if you, as you saw in the Cyber Resilience Act that's coming up, it's requested from suppliers to offer trainings and instructions also on cybersecurity. We already had that in place, but it's usually product driven. So if you buy a train from Siemens, then you have obviously a different training and a different training set than if you just buy a PLC, which is a kind of controller. So it's a very specific product-specific trainings or manuals are available on that. Yeah.
And another question is, so one of the users pointed out that there will be probably some developments, so indicating that, there will be Industry 5.0 and, even 6.0. And the question is whether you are aware of certain areas that are of particular importance, for operation technology systems, and which areas they would be, and what are the changing requirements to ensure that these systems are also secure in the future?
Good question. Well, looking at the future, I'm not sure when the Industrial Revolution 4.0 will stop and when we start calling it 5.0. That's usually something that you do in hindsight. What currently one of the developments in the OT world is the digital twins, and that's something that's coming up fast. And a digital twin is actually the virtual virtual duplicate or the twin of the real world example. So if you nowadays would build a production line, then you would first build it completely virtual, and you can do testing and simulations in this production line to see what changes you can in the virtual environment. You can check for changes, etc., before you build it. When it's built, your digital twin will give you the opportunity to test maybe new firmware, new hardware, new settings of the system, and see how that affects the entire production line. So and that this is kind of production line, but there are virtual digital twins. For example, my colleagues from mobility, they have virtual train stations. So the digital train station, a duplicate of a real train station, to manipulate what happens if someone jumps on the track. What will happen with the train traffic? How will they stop? How will all these systems react on that? So that would be the upcoming or the ongoing new thing, will be something with digital twins, which makes you a lot of these systems more relying on the IT infrastructure. So it will become more important. So cybersecurity of those kind of solutions will be a key element. That's something that we at Siemens recognize, but obviously we are not the only one. So cybersecurity is definitely the number one topic for a lot of technology providers in the future. And I'm not sure whether it will be 5.0, 6.0, but it's definitely something that we're looking at. Yeah.
Okay, and another question, which I think is like very relevant for our students, is that what are like the most trusted global forums or platforms, websites, further resources that students or anyone interested in the in that domain can access to stay updated on developments in the field. Exactly, and also like more specific topics such as industrial cybersecurity, I think was mentioned, and also threat intelligence. Exactly.
Well, there are a lot of websites. So a lot of governments are focusing on this as well. So National Cybersecurity Center for the Netherlands, it's a National Cybersecurity Center who has a special branch for OT security as well. And that's the case in a lot of countries as well, where you can sign up, especially if you work in the critical infrastructure. So there's so-called ISACs. I'm not sure if that's covered in this training, but information sharing communities where you share threat analysis on a very confidential basis. But there are also sites from suppliers. So I can only speak for Siemens, but there are multiple others as well. We have a Siemens Cert. So you can go to the Siemens Cert site and register there, and then you get all the updates on Siemens and third-party products that are available. So threat analysis and CVEs are available there. And there are industry organizations as well, especially focusing on OT. Now, usually these are kind of regional or maybe even national kind of organizations and groups. So there might be, depending on where you are on the globe, there might be some organization representing that.
Okay, thank you. I see we don't have that much time left, unfortunately. But another thing that I think is like relevant or important is the question: if someone of our students is interested in pursuing a professional career in OT, what sort of advice could you give them? What skills would be important, and what in which areas maybe can one also specialize in?
Okay. Good question, and also difficult to answer, to be honest. As OT is a very broad domain, I think it's more differentiated than the IT domain is. So you can imagine if you talk about a train as an OT system, or you talk about the electrical grid of a country as an OT system, which are both OT systems, the knowledge that you need to have can be very different. So you need to understand trains, or you need to understand energy systems. So there's no specific training or education focusing on OT systems. It's usually that if you would start working in energy management for some kind of national grid, then your prime task will be keep the system running, and your secondary task would be understanding the cybersecurity aspects of it. That's why this convergence, which I discussed, is sometimes kind of hard, because IT security is not necessarily the same as understanding your energy grid, and the other way around as well. So someone understanding the energy grid is not necessarily understanding all the ins and outs of a firewall setting, for example. If you can bridge that gap, you definitely have a job, and probably a very good job. So it needs some specialization in OT, but if you bring on board your expertise that you're doing in trainings and education like this, bringing IT security knowledge into the OT domain, then you definitely will have a good job there.
Okay, thank you so much. Yeah, I think that makes sense, because if we have like different OT systems, and it's kind of hard to say, okay, this is like one career path to pursue. But I hope that made it clear to the students, so that first, they train like in a specific field that they're interested in, and then take care also of the OT security, if I understood correctly.
Yep, definitely.
Okay. Since we don't have, like, our time has run up, I would thank you. Well, I would like to thank you, Johan, for your lecture. Me personally, and I'm sure also our students enjoyed it a lot. Me personally, I took a lot from it, actually, and also more new learnings and everything. So thank you for being with us here.
Was my pleasure. And if something pops up, my email address is on the slide, which you just see. So feel free to reach out if needed.
Okay. Thank you so much. We will also share the I think the presentation later. And okay, perfect. Then the students have access to that too. Then I say thank you again for your presentation, for your time as well. Have a nice afternoon later. And also to our students, thank you for being here with us.
Thank you. Bye-bye.
Bye.